Hi everyone, good afternoon. My name is Christy Maver. I'm VP of Marketing at Numenta. The talk of my title today is Transforming AI Through Neuroscience. So I'm going to talk a little bit about neuroscience, a little bit about AI, and I'm going to take no more than 10 minutes trying to convince you why AI needs neuroscience more than ever today, talk about the impact we're making in the short term and our long-term roadmap. So let's get started. So I start with this slide, which shows that for the past 30 to 40 years, the amount of compute required for AI systems has just grown tremendously. So if you look at the left, the y-axis, you'll see that's a log scale. And if you do some quick math and some sustained squinting, you'll notice that's a 10 billion-fold increase in compute required for AI. And if you look at the x-axis, you'll notice that ends at 2020, so it's only gotten bigger since then. And that's the red curve, the AI deep learning curve. Now, if you look at the blue line showing hardware performance, that's a pretty respectable growth as well, remembering that's a log scale, and so that's shown improvement too. But it's the gap between these two that's really driving complexity and cost and frankly preventing many companies from getting started or deploying large AI models today. So we need to bring these two back into alignment. And how will we do that? Well, the hardware improvements are great, but on their own, that's not going to cut it. We need new innovation, we need new algorithms, we need something new to help bridge this gap. Well, the brain is larger than any LLM that's out there, and it can run on about as much power as a normal light bulb. So why not start there? Can we start there? Can neuroscience truly improve AI? Well, we think it can. And we understand a lot of the details that make the brain so efficient. We understand the strategies and the mechanisms that the brain uses to operate in this efficient manner. Now, I'm not going to go into those neuroscience details here. That's a different talk. That's a longer talk. That's someone else's talk. But I am going to talk about two key components of the brain's efficiency that we can apply to today's AI. So the first has to do with the neuron. A deep learning neuron is really pretty simple. It really doesn't represent a biological neuron, which is fine. It's mathematical, so it's essentially a linear weighted sum followed by a nonlinearity. Now, a brain neuron is completely different. It's highly complex, it's very complicated, and we have these sparse distributed computations that allow the brain to use with very, very minimal energy. And then when you look at the neural network, on the deep learning side, essentially it's brute force, right? You multiply everything by everything, you're generating a lot of power, a lot of compute. And again, in the brain, that's not how it works at all. So if you look at the entire system, we have a sensory input that comes in. The brain can automatically understand its context and dynamically activate a tiny, tiny portion of neurons that are needed to process that input. And we're talking like 99.99% of the neurons are not required for any particular input. And that's pretty amazing, right? If you were to freeze frame any moment in your day today, very few neurons are actually involved in that particular moment. So the brain is able to allocate metabolic energy very efficiently. And we understand the algorithms that underpin these two concepts. And by applying that to AI, we can make AI more efficient. And that's what we've been working on at Numenta for many years. So if you're not familiar with Numenta, we were founded in 2005 by Jeff Hawkins and Donna Dubinsky. It's the same team that did Palm Computing. If you remember the Palm pilot back in the day, that was Jeff's creation. And Numenta was really founded on a dual mission. The first leg of that mission is scientific. It's to understand how the brain works so that we can carry out the second leg of the mission, which is to apply those discoveries and that research to AI and ultimately, eventually, create truly intelligent machines. So for the past 2 decades, we've been working on this neuroscience research. We've made a lot of progress and some breakthrough discoveries in understanding specifically how intelligence is implemented in the brain. we published a theory of that intelligence called the Thousand Brains Theory. Jeff wrote a book about it, which came out a few years ago called A Thousand Brains. Bill Gates named it to one of his top 5 books of 2021, the year it came out. And since then, at Numenta, we've been building AI technology on top of that theory. So far, we've been able to demonstrate dramatic power and performance improvements, notably for LLMs running on CPUs. We also, earlier this year, a few months ago actually, in June, we announced a new open source collaborative research project that's funded by the Gates Foundation called the Thousand Brains Project. And that's devoted to creating an entirely new type of AI based on these biological neocortical principles. Okay, so what does it mean to transform AI through neuroscience? If I'm going to put that as a title of the talk, I should at least address what that means. So essentially what we're doing is we're translating neuroscience to computer science. So we've taken components of the theory, we've created new architecture, data structures, and algorithms. So architecture being how information is physically structured in the brain, data structures, how that information is represented, and then the algorithms are how you operate on it, what you do with that information. And I've covered some of these in the key principles, showing that in the brain we use a more sophisticated neuron with active dendrites, we have sparse weights, we have sparse activations. In the Thousand Brains Project, they're looking at building entirely new sensory motor learning intelligent systems. So again, we're taking this research, we're mapping it to AI, both short-term and in the future. And then what are the results? What's the impact of doing that? Well, so far we've been able to show improvements in these 3 categories. So for inference, we've been able to show that we can dramatically accelerate throughput. We can do this with super low latencies that require much less memory, that use much less energy. On the training side of things, we're able not only to accelerate training, but also to do it in a way that requires much smaller training sets, less data labeling, and giving you the ability to update models on the fly rather than having to retrain the whole thing. And then lastly, on the hardware side of things, one of the nice things about what's come out of this research is that we're able to optimize this for commodity hardware. So specifically, we've done a lot of benchmarks on CPUs, also GPUs, enabling low precision AI, and then ultimately laying the groundwork for completely new hardware architectures that are designed from the beginning to take advantage of these software optimizations. We've shown to date in many of these categories up to 100x improvement, and as we continue to implement portions of our neuroscience-based roadmap, we expect another order of magnitude improvement over the next 2 to 3 years. So let me show you just a couple of the results that we've gotten so far. So this first one is a power benchmark that we ran. This is power defined as throughput per watts. And we're looking at Numenta technology running on a 5th gen Intel Xeon CPU compared to an NVIDIA A100 GPU. And Numenta on the Intel CPU is 20 times more power efficient than the NVIDIA GPU. Now, if you're looking at the footnotes, you may see that that's a BERT large model. So let's look at a GPT model. This is a result that's looking at speed, well, throughput specifically. And again, this is a Numenta, this time it's a GPT 7 billion model running on the Intel 5th gen Xeon compared to the Llama 2 7B running on NVIDIA A100. And here we see a 3 to 6x throughput speed up. And that's pretty compelling considering that, I think most people associate running large running large AI models on GPUs and not CPUs. So the ability to get all the benefits and the flexibility of CPUs and still get this performance increase is quite nice. So to summarize, in the last 20 seconds, at Numenta, we're steeped in neuroscience research, but we're really excited about the results that we're seeing today and the future that we're setting for tomorrow. and we'd love to chat more with you about it. Visit Numenta.com. I'll be hanging out at the Numenta Lounge at booth 232. If you're interested in joining the open source community, please do. You can scan that QR code. That'll take you to the Thousand Brains project, and you'll learn how to get involved. Thank you so much.